So welcome everybody. Happy Monday afternoon. And my name is Mike Farian, and today we're going to spend the next 30 minutes or so talking about open architecture solution design and how Advantech and Inductive Automation's use of open architectures enable and accelerate innovation with our partners in their solutions. So to kick this off, we should really start our conversation with a discussion about open platforms. So, a dedicated appliance is a piece of hardware that's purpose-built for a singular set of functions. And if you need to add more functions, you end up adding appliances, often with large degrees of replication between them. Whereas an open platform allows you to pull on a whole ecosystem of providers and define the applications, typically just by adding more software. So, for example, remember when, if you wanted to record video, you had to go buy a camcorder, and you wanted to get up on time, you bought an alarm clock. You wanted to take pictures, you bought a digital camera. You wanted to go hiking, you bought a GPS. So that was the world of dedicated appliances. But that's increasingly a problem in today's world of solutions. When you want to build a solution using dedicated appliances, you buy more and more appliances, you figure out the interconnection and the integration, and it becomes this linear relationship. So if you want to add another function, you have to add another appliance. But in today's world, we can typically have software-defined appliances running on top of a common hardware platform. So now when we want to add a function, we can often just simply add another software application, extending the value and the flexibility of the hardware that we already own. So when we build solutions on open architectures, we really reduce vendor lock-in. And we open this massive ecosystem of hardware and software providers. And it gives us the maximum utilization of the compute resources that we already have, typically reducing the required hardware footprint. And it provides a scalability, not just for growth, but also flexibility. And that's really important in today's world of IoT type solutions, digital transformation type solutions, because we have to be able to adapt on the fly to yet undiscovered use cases. And I should pause here just for a moment and just point out how different this is than the world of legacy automation. So for much of the last 30 years, the world of legacy automation was focused really heavily on closed proprietary vendor systems. And there's a lot of effort invested in creating very deliberate vendor lock-in. So let's take a look at Advantech's approach. So Advantech is first and foremost a hardware company. We're a hardware company that leverages open architectures to create solutions at really every level of the hardware stack. So starting down at the very edge, where the physical world first meets the digital world, we have a huge range of sensing and data acquisition products. These products allow you to connect to real-world signals and convert that sensor data into digitized open standards, whether that be an industrial protocol like Modbus or maybe a more IoT-facing protocol, something like a RESTful interface or MQTT. Then going up a layer, we have products for industrial communications. Again, these products focus on open architectures and standards. Things like rugged Ethernet switches, fiber optics, LTE, 802.11, and also leveraging other standards across the portfolio, things like power over Ethernet, for example. And then we have edge computing. Here again, we focus on open architectures. So x86 and ARM-based hardware running common operating systems like Linux or Windows. And this all adds up to a huge portfolio of open architecture hardware. So this enables you to mix and match with other best-in-breed products and peripherals to create really a best-in-breed solution, not one that's just the best you could do when you're locked in with a particular vendor. So as a hardware company dedicated to open architectures, it's not a huge surprise that we have such a complementary relationship with Inductive Automation. So Inductive Automation is a software company, and they took on the world of industrial SCADA with an open architecture vision. They focus on enabling engineers to innovate, removing technology and economic barriers. So I'd say the inductive approach really filled a void in the market for an industrial platform that was built on open architectures. And let me harp on this point for just a minute. Traditional industrial automation software platforms weren't really focused on being sold as tools for innovation. And what always bothered me about them was their pricing model. So they used a pricing model that was really designed to mimic a dedicated appliance, a piece of hardware. So imagine this is 1995 and you want to go out and buy a word processor software package. But the price for that word processor software isn't $99. The price goes up when you write a longer document, or the price goes up when you save more documents, or the price goes up when more people read your documents, which is absolutely crazy, but that's how traditional automation software was priced. And the challenge in that is if that's how your software is priced, you're going to spend more of your time figuring out how to minimize your use of the tool instead of how do you innovate with the tool. So again, that's kind of the world of legacy automation software, and it drives me nuts because I see so much time lost on cost avoidance instead of focusing on how can I make best use of these cool engineering tools. So with Ignition, because it's built on open architecture concepts, it's not constrained also to just industrial SCADA applications. It's really turned out to be an outstanding platform for OT-IT convergence, industrial IoT applications, and digital transformation. So let's take a look at how Inductive really embraced open architectures. And this is my perspective. So there's really two sides here. One is their technical approach. So it's a web-based tool, web-based architecture built on Java, Python, and SQL database compatibility. But that's really only half of the challenge. The other unique thing about Ignition is really their business approach. And this is equally open. So a very fixed, transparent pricing model. And also a highly engaged user community that they really foster through free training and really enabling this community out there. So really, you find a lot of opportunity with engineers that adopt Ignition. That there's no additional charge to add a new feature in terms of I want to add 50 clients instead of 5 clients, or 5,000 devices instead of 500 devices. No limit to amount of tags and things like that. So that allows the engineers to go try things without having to go back and say, well, geez, I wanted to try this, but it was going to add a bunch of operating, OpEx costs to the price of the solution. So let's take a look at another aspect here. And this is really a critical design approach you need to take. And it's really enabled by open architectures. And that's the ability to decouple your assets from your software applications. So when you tie an asset directly to an application, you really hamstring your ability to scale and build flexible solutions. And it makes it hard for those to meet future business needs without getting into rip and replace type cycles. But instead, if we connect our assets into an infrastructure, then we connect our applications into that infrastructure, then we achieve a really flexible and scalable design. And one way we do that with things like Ignition and open architecture solutions is, we're using native MQTT edge devices, or we're using Ignition Edge onboard gateways to connect into legacy assets. And then again, the clients are web-based. And so basically we have all the clients, or all the edge devices and gateways reporting into an infrastructure, and then the clients and the applications coupled into that infrastructure as well. So again, that allows us a lot of flexibility to change and add to a design without having to rip out everything and kind of start over every time. So let's go back and take a look at how this overlays so well with Advantech. So first, we build hardware solutions that fit into business critical and mission critical applications. This is across automation, iFactory, industrial equipment manufacturers, energy and environment, smart transportation. And then we also focus on our edge compute hardware. So whether it's a rugged fanless edge compute device, a rack mount server, or a GPU-based machine for AI applications, all these are open platforms that can leverage a vast ecosystem of software and hardware, including Ignition Enterprise and Ignition Edge. And then every project requires networking. So we've got a huge portfolio of both wired and wireless standards-based networking products. So whether you need copper, fiber, cellular, or Wi-Fi, we've got your networking solutions covered. And most importantly, out at the very, very edge of the network, where we need to connect that physical world into the digital world, we've got a huge range of data acquisition, I/O, and wireless sensing products. And these products can natively speak, MQTT, which makes it easy to connect them into decoupled architectures, such as inductive automation. So with that said, let me take just a short detour, so a little bit of bonus content here. And I want to talk about virtualization. So when we build solutions on open architectures, we open the door to some really great and valuable technologies. And virtualization is one of those. So virtualization, a lot of us are familiar now with virtual machines, have been around for a while in the world of servers and cloud in particular. And virtualization really enables us to run multiple applications independently across one or many hardware platforms. So essentially what a virtual machine is we're taking one piece of hardware, so one computer, whether it's an edge device or a server, we're running some special software on top of that called a hypervisor. And then we can create a virtual machine, multiple virtual machines in that one box that are really isolated from each other. So every virtual machine bundles an operating system, the application itself, and any of its dependencies together. And that makes virtual machines really easy to replicate across different hardware platforms, or just replicate to create many replicated applications. But what about when we want to take a virtual machine outside of the data center? So this becomes more of a challenge, because in a virtual machine, remember, we're replicating the operating system with every virtual machine, and that carries a lot of overhead. So if you have 6 applications on there, you would have 6 copies of Windows or Linux or a mix and match of both. So when we move out of the data center out towards the edge, we end up constrained with more constraints. We have typically hardened devices. They're probably fanless. They're installed in cabinets with no airflow. So we have to have wider temperature ranges and often have to have smaller physical footprints. So in reality, virtual machines are a great fit in data centers, on-prem or cloud-based data centers, but they don't fit so well out at the edge of networks. So there's a new form of virtualization that's called containers. And containers provide a lower overhead virtualization solution. So in a container, we share the operating system across all the applications, so it's much, much leaner. So each container holds its application and those dependencies and libraries and settings. And so it's still fully decoupled from the physical hardware. And the containers are isolated from each other as well as the outside world. So the integrator is the one that creates all the interconnections, opens ports to the outside world or between containers, and they're all made over a virtual network. So there's some advantages of virtualization. When you look and say, I want to virtualize a solution, we create a lot more resiliency. So every container is isolated from the next application. So if one of your apps crashes, it doesn't bring down the whole machine. It can just automatically restart, which, remember, we're not rebooting an operating system, we're just restarting an application. So it typically takes seconds, not minutes. And portability. So it's really important that containers, because they contain all the dependencies, we can take one application that's containerized and migrate it across hardware platforms. So you might have the same application deployed on an ARM platform or an x86. So that makes scalability and portability really much, much easier. And then scale. This is really important. So containers can be deployed very quickly, so it makes it easy to take one solution and deploy it thousands of times, even across different hardware platforms. And because it's portable, they can be deployed on larger footprints or smaller hardware footprints. And then portable over time as well. So you'll find if you deploy a solution on a PC-based architecture today, and then you want to add 25 more units to that 6-7 years from now, your hardware specs are going to change. We have a different processor, more memory, different things like that, and different drivers behind the scenes. But this creates this portability because all the dependencies are packaged with the application, and we're decoupled from the hardware. Now we're portable across time as well. And then if we do this properly and break up our application into specific containers instead of creating one massive monolithic application that has a user interface and a database and all that stuff kind of compiled together, if we do those in independent containers, we can distribute containerized components across different machines or up and down the stack. So part of the application might be out at the edge, right on the factory floor. Another part of the application might be in the on-prem data center, and yet another part might be up in the cloud-based data center. So security is interesting as well because each container gets its own virtual network stack with no access to sockets or other containers unless specifically configured, there's a capability to significantly reduce the number of external attack vectors within containers. Although with that, I'd always put the caveat out there that it's always up to the integrator to take advantage of those security tools and deploy those properly. So speed and agility is a huge benefit of containerized solutions as well. So you can easily stop, start, or move a container. And what we typically find in today's world of digital transformation or IoT, or however we want to call it, we often are discovering new use cases as we go. So we need that flexibility to say, hey, we started collecting all this data and we got it 2 years into it, things are going well, and then somebody said, hey, let's add this other application. Well, you don't want to rip out all this hardware or put your original applications at risk to go and re-engineer the system. But here we can just deploy yet another container on the same piece of hardware without disrupting existing solutions. And if things are growing wildly in scale, now you need to start thinking about sharing or balancing load resources across hardware platforms. Then you can add in container orchestration tools. You may have heard of things like Kubernetes are becoming very popular. That's a way to manage and maintain and scale up and down your containerized solution. So Docker is something you may have heard of, and this has become the dominant flavor of container technology, and it's really had massive adoption since 2014, and we're really starting to see it come very kind of fast and furious into the industrial IoT. So Docker is part of the Linux Foundation Open Container Project, so even other container technology still supports Docker images. And from the market perspective, I'm starting to see a lot of customers coming in with their RFPs with a Docker requirement. Say, hey, look, we need the Docker environment here. We need to be able to support that environment in our hardware solution. So that's the end of my little technical detour here. So like I said, there's kind of a bonus content, if you will, but it's all about when you go and embrace these open architecture type solutions, you get the opportunity to use tools like this. And if you're interested in learning more about building virtualized solutions using Docker containers, we're about halfway through developing a video workshop series that introduces this technology and includes hands-on, how to build the environment and how to build an application here. So we've got the first couple of those video sessions done. So watch your inbox for news from Advantech Marketing, or just drop me a note and I can get you in touch with the first couple parts of that series. Okay, so back to Ignition. So Advantech has partnered with Ignition Inductive Automation to join their Ignition On Board program. So we've launched a whole series of industrial gateways, HMIs, and even some specialized Class 1 Div 2 products that are certified for HAZ locations. And these come pre-bundled with the Ignition Edge software. So we've got embedded gateways and edge industrial compute devices that range from our smallest Uno, which is a large pocket-sized device, just would fit in your pocket, and scaling all the way up to Core i7 processors. We got wireless connectivity options from Wi-Fi, Bluetooth, LTE. We've also got HMI versions of these. So these are kind of touch panel PCs. They've got the edge compute built in with a HMI panel in 10 different screen sizes, all the way up to IP66 and even IP69K protection. Some stainless steel for food and bev and pharma type applications. And like I said, even some Class 1 Div 2 devices. So if you're in oil and gas or water treatment or things that require HAZ location ratings, we've got a number of devices with Ignition on board there as well. So here's a quick introduction of some of these edge compute platforms. We're proud of our ruggedized industrial design for harsh environments. And also, very importantly, we understand that when you deploy a lot of industrial computing applications, they're going to be running out in the field for 5, 10 years or more. So you need long-term availability and seamless transitions from legacy to latest models. So when we launch new industrial PCs, we assure that there's a supply chain longevity in place for at least 5 to 7 years. And we're very focused on industrial automation applications. So these products are designed with automation from the start. So when you compare them to commercial market PCs, our edge platforms provide a lot more features such as digital and analog interfaces, field bus communications, DC power inputs, wireless connectivity, and such. So if we look at the Ignition Onboard bundle, I mean, certainly some advantages for the integrator or solutions provider to have Ignition Edge pre-bundled. So first, these have been certified both by Advantech and by Inductive Automation to be sure that there's no worries about software compatibility or resource conflicts and such. And it's certainly easier, kind of a hands-free deployment. So when you purchase an industrial PC with Ignition on board, it's built through our configure to order service. So that gives you the ability to specify not only do you want Ignition on board, but what's the compute power you need, what's the I/O you need, what's the storage you need, and things like that. And as usual, bundles enable better pricing. So there's pricing advantages of buying the pre-bundled solutions. So it's really a pretty simple three-step process. I put a short link here, and you can download this PDF file. It has a link on board too, or just Google Ignition and Advantech on board, and you'll get right to our website. But basically a three-step process. You bring up the website, and then you're going to choose your platform. So what is it that you want? A wireless gateway with a lot of communications options? Is it an industrial HMI? And then you'll configure your system options. So this is, how much storage do you need? What kind of drive? What kind of memory? What level of processor power and such. So very simple ordering process. When you place your order, you're getting not only the hardware, but you're getting Ignition Edge pre-installed along with its license. So it's very seamless for you to deploy out in the field. So a few quick case studies to go along with this. So this was a automotive tier 1 manufacturer, and very much an Ignition house. So they were basically deploying an industrial IoT solution to get better visibility into their legacy assets and provide traceability all the way through the parts they manufactured up to their customers, who's automotive manufacturers who have a lot of demands for traceability these days. So they deployed Ignition, and they using Ignition Edge, they were able to talk to their legacy controllers, all the PLCs and RTUs out in the field. They're talking field buses, and very easily integrate data from those remote assets and those factory deployed assets up into their system. But then they also had devices that had no field bus. They were 30, 40-year-old pieces of equipment controlled with relay logic. So to do that, they used the Advantech Wizard wireless mesh sensing products. So these are wireless sensing products that grab sensor data and publish it natively over MQTT. So again, very easy to adapt, right into the Ignition platform. So another case study would be a large oil field application. So these oil fields can cover several hundred square kilometers, and then you often have linked oil fields not too far from each other. So managing these can be, quite the process if you want to get real-time monitoring and even some controls in place. So in this case, the customer used a range of products. They were using Ignition server back in their central control room, but they wanted to get assets from the edge devices out in the field. So they deployed one of our automation computers with Ignition on board, Ignition Edge, and then they they needed I/O data. So using some of our Atom modules, they're able to go out and say, well, let's get the torque and the voltage and the current off each of these motors so they can monitor all the pumps out in the field. And doing this all over LTE-based communications, as well as deploying a local HMI. So when there was somebody on site, they had a very rugged stainless steel housed monitor and HMI out in the field for the field staff. And a fairly typical application, so another pump monitoring solution. So in this case, they had a local PLC and control system, but really wanted to add in remote connectivity. So again, using Ignition Edge on board an automation computer, in this case tying through a fiber network that they deployed using fiber ring switches and back into the Ignition central control room. So very typical kind of legacy brownfield application. And I would even say if you're doing this from a greenfield, if you're designing this from the ground up, you would most likely even eliminate this PLC and say, well, why would I deploy a dedicated appliance instead of just virtualizing that PLC inside the automation computer. So, wrapping things up, and feel free to pop anything into any questions into chat. But really my key points here, what you want to do in design today is we want to marry open architecture software with open architecture hardware to give us the best flexibility and scalability and the best total solution cost in the field. And then start to take a look, this virtualization technology is really pushing its way out into our industrial world here. So keep your eyes on how you can leverage virtualization and container technology in your solutions. And finally, using Ignition onboard device bundles can really help simplify and accelerate your SCADA, your industrial IoT, and your digital transformation solutions. So with that, that's all I have for you today. As always, if you have any questions or follow-ups, certainly feel free to reach out to me. My email address is on the slide there. And thank you very much for attending today, and have a great afternoon.
I appreciate it. Let's hold and see if there are any questions coming in real quick. If you have any questions, please chat them in. I don't see any questions coming here, so we'll go ahead and wrap things up. I appreciate it.
Perfect. Thank you, everybody.